Welcome to this small series of videos on concurrent programming. If you do any kind of professional software development, you will need to have these tools in your arsenal to write concurrent programs. Today, we'll learn a little bit about concurrency. You need to know at least one programming language to understand this series of videos. I will focus on Python and JavaScript. But don't worry too much about the syntax or the language and focus on the high level concepts instead. Also, we need to first do some groundwork before diving into writing concurrent programs and understand why concurrency is required. First, let's start with the definition. So, what's concurrency? We'll first start with the general definition and then move on to the programming one. Well, the general definition says the fact of two or more events or circumstances happening at the same time. What does the programming definition say? It says a form of computing in which several tasks are executed in overlapping time periods instead of sequentially. So the most important word there is overlapping. So you can think of use cases yourself where a bunch of programs run in overlapping time periods, such as in your operating system. The operating system ensures that you can play a game while listening to your favorite song, even if your CPU has only one core. So, I hate slideshows as much as you do. So, let's do a quick live coding session and then come back to the slides. Okay, so I've started my Python 3.6 interpreter and I'm now a professional software developer and I have a client. The client asks me to write a square function. So I'm like, okay, I know how to do that. And then I'll just do return n times n. And then everyone's happy. Well, not really. Now the client says, oh, this is cool, but I want, you know what I want? I want a sum of squares function. So you're like, okay. And then you say sum of squares from start to stop. And then return sum of square of I for I in range of start to stop. So, and then you test your code interactively. And you think it works. So if you're not familiar with Python, I'll just show range and sum. For I in range of 1 to 10, print I, just prints the numbers, and then sum is a built-in function, and that's about it. But life does not end this way. You're not happy. The client comes back for more. They want analytics and they want to make some external API calls. So your square function becomes like really slow. And now you're asked to write a slow square function with these additional features. So you're like, okay, here we go again. And then you do import OS, import time. We'll come back to this later. And then you do a slow square function with n as usual, and then the sleep function. So I'm using sleep as a proxy for making an external API call. So the external API call does take some time, so instead of that I'm using sleep. And then also show progress, where we show at what iteration we are when doing the square thing. So this is not Pythonic code, this is not production code, this is just an example to show the concept. So you do for I in range of n, result plus equal to n, and if show progress, then you print the number and the iteration and also the PID, or rather the process ID. So I'm just writing all these parameters that you need to print. And we use the OS get PID function. So this loop appears each time we increment the result by n, and then we sleep for the specified time period. In this case, it is the sleep variable. And finally, we return the result. And now we just test it. So let's say I want to compute the square of 4. And then sleep for 0.01 seconds between each loop, and then show progress false. Oh, just a minute. I just need to print the return keyword here. Yeah, so if I do this, I get the value 16. And if I sleep for a longer duration, then this function gets a little bit slower as well. If I sleep for 1 whole second, you can see that it does take around 4 seconds before we get the answer. Okay, so now we have this low square function, and this low square function is unavoidable. We have to use it somehow. But the client still wants the sum of squares function as well. So now if we do sum of squares, our function becomes really slow because we need to call slow square on many numbers. So we have start, comma stop, and then return sum of slow squares, verify false for I in range of start, comma stop. So now if I do 0 to 10, well, it's quite slow actually, compared to the previous one where we just did sum of squares, where the result was almost instantaneous. So can we improve the situation? That's where concurrency comes in. I'll see you at the next video.